Welcome to Evolution in Controls. I'm your host, Tim Wilson. Thank you for joining us. Today's episode is one of several in our series on the mobile and off-highway equipment market. There's a real drive underway today to improve machine safety, machine performance, and machine capability. The driving force behind this movement is, of course, technological advancement. New technology makes new things possible, but advancements in technology can be a two-edged sword, and the cost is always a consideration. As machine builders or operators look to incorporate new technology into their machines, all technology is not the same. The impact of that technology on machine design and construction is every bit as important as the cost of the technology itself. And when there are different choices of technology, the question of why choose one technology over another becomes very important indeed. Are there inherent drawbacks or limitations that come with a cost? Can they find a partner that understands the technical benefits without ignoring the drawbacks or limitations? When the control of a large, expensive, and potentially dangerous piece of equipment is relegated to new technology, the wrong choice can have big consequences. Here to help us work through some specifics of bus communication is Mr. Fritz Jaessing. He's an account manager for Marel's newest subsidiary, LOR Mobile Controls. Fritz, thank you for joining us.
Thanks for having me, Tim.
Let's start by talking a little bit about LOR. Who is LOR?
Sure. LOR Mobile Controls is based in Central Michigan, and we engineer and manufacture custom control equipment for our OEM off-highway customers. So, control equipment might be a radio and remote control, might be a machine start panel, maybe a display for CAN bus information and control, maybe a wiring harness and a power distribution kit, on some of the newer Tier 4 final or Stage 5 engines, things of that nature. Anything that might control an off-highway machine.
You said custom designed and built, so you do all the engineering there at LOR and you do the manufacturing there as well?
That's correct, yep. Everything we do right in-house in Central Michigan. So we have an engineering staff that does a really nice job with the design process and things like that, and then our entire manufacturing team.
Okay. Well, you mentioned in your description, you mentioned CAN bus. Tell me a little bit about CAN bus or even just bus systems in general.
Sure. So with the electrification of vehicles these days, and most of the engines we're dealing with, I mean, even look at your cars, they all have computers on them now. They call them ECUs or ECMs, engine control units. And they are running all the engine information and functionality for that piece of equipment, cars or otherwise, through a CAN bus. And the CAN bus is basically a communication layer that's on the machine, connects all the important parts. And the language that's spoken in most cases is SAE J1939. It's a standard language for machine control or microprocessor communication.
And so the bus is a series of wires that connect all of these devices?
It is, but I don't want you to think of it in the same terms as like discrete wiring. So it will have 4 wires that connect everything together as far as power and ground and your CAN high and your CAN low. If you can run those wires to each of the nodes or each of the pieces on that CAN bus trunk line, then you can have a whole variety of control. When you think about a discrete wiring, for example, sure, wires, but there's going to be a knuckle of wires, and it's going to be a lot of them because every switch and every display and everything's going to have a wire to it, or at least one, right? Which means you're going to have a whole bunch of cabling all over the machine, whereas if you're using a CAN bus system, most of your control is into the firmware. It's programmed into the software that runs through those 4 lines.
So the bus system dramatically reduces the number of wires is what it seems to me.
Well, that's for sure, yes. And so once you can control everything using the onboard computer, right, you can get a lot more flexibility about changing designs or maybe adding and taking away pieces. So let's say, for example, that you want to add in a bank of switches somewhere on your machine. Sure, you're going to have the 4 wires coming out of that to connect it to the CAN bus, the trunk line. But then you just go into programming to figure it all out. If you did not have the CAN bus there, that bank of switches, however many there were, you might have 2, 4, 6, 8, 10 wires coming off of that same thing to go in. And so think about if you want to change anything in a design, that's a whole lot of work for somebody to go through and rewire an engine. Or think about maybe troubleshooting. Hey, you've got a failure somewhere. it might be more difficult to figure out which wire is actually broken. Well, with things like the CAN bus, you've got diagnostic information built into that system.
Is there something on that bank of valves that the CAN bus connects to? Is there something that hooks into that bus? Is it what do you call that? Is it a node? Is that what it is?
Sure. So yeah, the CAN bus line is basically a trunk line. Yeah, I'm going to say it's just one long run. Think of it like a river or a vein or something like that. And then you'll have your nodes breaking off of it for whatever your control things are. So you might have one for a display monitor, for example. You might have one for a bank of switches or a radio remote or a valve or something like that.
And the programming that you were talking about, that resides partially in that node. The intelligence is there.
Sure. So like we would program in the firmware, we would call that, in the J1939 language into our receiver or into our display or something like that, so that it can communicate.
Well, if a customer comes to you and wants to implement something on the CAN bus, what does that conversation sound like? How does that go?
Yeah, so usually when a customer comes to us, one of the first questions after we ascertain the application is to simply ask them, are you using a CAN bus system? Are you using an electronic engine? Do you already have CAN bus on the system or on the machine? And if they do, then we will try and push them towards a CAN bus controller.
What about if they don't?
Well, then if they don't, then we're back to the discrete wiring, which is what we've been doing forever. So this is what we're innovating to, right? Is trying to get us to integrate onto a system that's already there. And what does really well for them is if they do have CAN bus on there, they can choose, if they want to provide LOR with the mapping for that CAN bus system. The mapping would be, what functions do what and how are we going to set it up in that communication layer. If they don't have that capability, if that's not in their wheelhouse, then we can do that. And then we would set it up for them. We would just need a function list.
You'd go in and retroactively map what was already there.
Well, no, because this might be a new build, right? So we already know since J1939 is a standard, there's some standard things that are already being communicated on the bus. So we would come in, and as long as we know what their functions are, we could map them to our stuff so that it works and collaborates together. So
you started to touch on it, but what are some of the benefits of this bus? You've mentioned diagnostic. Are there others?
Sure. So the biggest thing would be flexibility, I would say. So when you think about the CAN bus system, it's all software programmed into our circuit boards. But for example, we have 3 different styles of radio remotes. We have a single handheld, a 2 handheld, and then this larger belly box. If they're all CAN bus controlled, we can use any one of those on that machine just using the mapping that's in the CAN bus. That wasn't the way it was before. It was if you took, the single hand control and you put it on there, it was all hardwired in. That's the one you were using. This button goes down, the signal goes down this wire to this function. That's it. With the CAN bus, you don't have that limitation.
Now, those devices that you're talking about, those are remote, right? Are those communicating via wireless to the machine?
Absolutely. So that's the great thing is we can connect our receivers and modules on the machine to the CAN bus as a node, I'm going to say, and we can send that information back to our transmitter, display it on a screen. So if you want to know what RPMs you're running, you don't have to walk over to the machine and look at, say, a tachometer or something. You just look at your display. If you want to know how much fuel you've used, just look at your display. So if there's sensors and things connected around the machine that are also connected to the CAN bus, we'll get that information back.
What's the business case for the equipment builder or the equipment owner to implement this stuff on CAN bus?
So one of the things I like the most is on a business side, and I know usually when we talk business we talk money, but the first and foremost would be the safety factor. So we say that using a radio to begin with is safer because it can get you farther away from the machine, give you more visibility, right, things like that. But consider this option. Let's say you have a mobile off-highway machine. I'm just going to use an easy example and say a stump grinder, and it's on tracks, and it can move and it can cut. But you don't want those 2 functions going at the same time. That's going to be a safety issue. So in the CAN bus, we can program it that if the cutter head is moving, I don't care how many times you push the joystick, that vehicle's not going to roll anywhere. So those are the kind of safety implications we can have. We can interlock different functions, which a lot of these machines, when we're talking about these off-highway machines, could have 20 or 30 functions on them. There's a lot going on, and many of those functions are interrelated. Don't do this until you see this happen on this side. We can do that in programming rather than wiring.
Discrete wiring.
Yes, and so that saves them a whole lot if they ever want to change that machine, if they ever want to do anything different. The cost to make those changes is not in hardwiring a machine. It's just into the software. So that's very helpful. And then the other thing is on the diagnostic side. So if you're connected to the CAN bus, you can read the diagnostic information of the machine. So if a function doesn't work, or if the machine shuts down, it'll throw a CAN bus code. You might get it on your radio remote transmitter so that you can see what's going on and troubleshoot it that way. With discrete wiring, it was all get out your multimeter, see where you've got a broken pin or where a wire got broken or things like that.
Does that mean that the equipment operators have to invest less in train people to diagnose it because it's easier to diagnose?
Well, I would say it's a different level of training. I still think there is a lot of value in having somebody that runs these machines, a well-trained operator that's used the machine for a long time. Will be able to diagnose things faster no matter how well trained you are, right? But it definitely helps.
It's a different knowledge set.
It is, and it expedites the process, especially as everything's becoming electrified. I mean, we're not going backwards. We're not really going to go back to this discrete wiring, and of course, you're always going to have a multimeter around. But the truth is that the CAN bus is really the future of engines, I think, and especially with us controlling them. So
electrification, we see it. It's coming. It's the future. Does that cement CAN bus and communication and CAN bus type of systems that LOR does? Does that kind of cement them for the future?
I would think so. I would think it's going to continue to grow. With every car, every diesel engine, everything has some sort of computer on it, and it's providing a lot of information and a lot of functionality that is super useful. And so for us to connect in, I think that's a really solid way forward, and I think that's just going to continue to grow. People want to see that.
You'd expect the next 5 years to just be continued growth given the electrification.
I would think so.
Sounds very exciting.
Well, we're hoping so.
Fritz, thanks so much for today for coming in and talking to us.
Thanks for having me, Tim.
You
Appreciate
bet.
it.
To learn more about LOR and their CAN bus communication system for the mobile and off-highway market, visit lormobilecontrols.com. To learn more about Marel and their systems and solutions, visit marel-group.com. Don't forget to subscribe to Evolution in Controls on whatever platform you use for podcasts or on YouTube for a video version so you can be updated when we release new episodes. Thank you again for joining us today. I'm Tim Wilson, and remember, keep moving.